Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x times 5 to the power of x squared is equal to 15. Now, 15, this is the same thing as 3 times 5. So now I have 3 to the power of x times 5 to the power of x squared is equal to 3 times 5. Now I'm going to go ahead and divide both sides by 3 to the power of x. So then these two would cancel out, and I would have 5 to the power of x squared is equal to 3 over 3 to the power of x times 5 over 3 to the power of x. Now I'm going to go ahead and divide both sides by 5. So then these two cancel out, and I would be left with 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. So now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n, right? Now, 5 to the power of x squared over 5, well, this is the same thing as 5 to the power of x squared times 1 over 5, which is equal to 3 times 1 over 3 to the power of x. Now, 1 over 5, this is the same thing as 5 to the power of negative 1. And 1 over 3 to the power of x, this is the same thing as 3 to the power of negative x. And remember, now I can also multiply these, and if a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 5 to the power of x squared times 5 to the power of negative 1, that's going to equal 5 to the power of x squared minus 1, which is equal to 3 to the power of 1 times 3 to the power of negative x is equal to 3 to the power of 1 minus x. Now I'm going to go ahead and take the log of both sides. So I have log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So now I get b times log a. So for log 5 to the power of x squared minus 1, I can move this to the front, and for log 3 to the power of 1 minus x, I can move this to the front. So now I have x squared minus 1 times log 5 is equal to 1 minus x times log 3. Now I'm going to divide both sides by log 5. And log 5 over log 5, that's the same thing as log base 5 of 5. And log 3 over log 5, that's the same thing of log base 5 of 3. If I have something in the form log base a of a, this is actually equal to 1. So log base 5 of 5, that's going to equal 1. So I have x squared minus 1 times 1 is equal to 1 minus x times log 5 base 5 of 3. Then this just means x squared minus 1 is equal to 1 minus x times log base 5 of 3. Now if I subtract 1 minus x times log base 5 over 3 on both sides, I get x squared minus 1 minus 1 minus x times log base 5 of 3 is equal to 0. And now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. In this case, a is equal to x and b is equal to 1. So x squared minus 1, that's going to equal x plus 1 times x minus 1. And now I have this plus x minus 1 times log base 5 of 3 is equal to 0. Because 1 minus x is the same thing as negative x plus 1, and negative of negative x plus 1 is equal to x minus 1. So now, if I factor out x minus 1, I get x minus 1 times x plus 1 times log base 5 of 3, and this is equal to 0. Now, this gives me two equations. I have x minus 1 is equal to 0, and I also have x plus 1 times log base 5 of 3 is equal to 0. For x minus 1 equals 0, I can simply add 1 on both sides, so I get x is equal to 1, and this is one solution of x. Now for x plus 1 times log base 5 of 3, oh wait, I made a mistake. This isn't supposed to be times, this is actually supposed to be plus, so this is plus. So this would be x plus 1 plus log base 5 of 3 is equal to 0. So now, if I subtract both sides by log base 5 of 3, I get x plus 1 is equal to negative log base 5 of 3. And now I can also subtract 1 on both sides, so I get x is equal to negative 1 minus log base 5 of 3. Now, if I factor out negative 1, I get negative 1 times 1 plus log base 5 of 3. And now this is equal to negative 1 times 1 is the same thing as log base 5 of 5 plus log base 5 of 3. And now if I combine these, I get negative 1 times log base 5 of 5 times 3, because these two multiply. And that is going to equal negative 1 times log base 5 of 15, which is simply negative log base 5 of 15. So that is our two solutions. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log phi to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.